Hello, in this video, I want to review topics from quadratic equations. Check the description for problems and timestamps. Let's begin with example number 1. I have to solve the equation by factoring. Here, I notice that my leading coefficient is 1, meaning that I can factor this by grabbing the two numbers that multiply to negative 28, but also add to 3. I'm going to use this X diagram to help me organize everything. So I need two numbers that multiply to negative 28 but add to positive 3. And after some trial and error, you're going to come to the conclusion that the numbers are 7 and negative 4. 7 times negative 4 is negative 28, but when you add them, they give you the positive 3. That means that I can factor the left-hand side of the equation as x plus 7 multiplied by x minus 4. And that's going to equal 0. Next, I realize that I have the product of two things, and that product is equal to 0. By the zero product property, I can set each factor equal to 0. So I can make this statement, x plus 7 is equal to 0, and x minus 4 is equal to 0. To solve for x, I need to solve both of these equations. I'll begin with green. To isolate x, all I have to do is subtract 7 from both sides of this equation, and I get that x is equal to 0 minus 7, negative 7. For yellow, to isolate x, I need to add 4 on both sides, and 0 plus 4 is going to give me positive 4. My solutions are negative 7 and positive 4. Let's practice another similar example. Example 2, solve the equation by factoring. Again, because the leading coefficient is 1, to factor this trinomial, I can grab the two numbers that multiply to 72, but add to 17. I'll use this X diagram to help me organize things. So I need to find the two numbers that multiply to 72, but add to 17. And after some trial and error, we'll be able to deduce that the two numbers are 8 and 9. 8 times 9 is 72. But if we add them, 8 plus 9 is 17. I can factor the left-hand side of this equation as x plus 8 multiplied by x plus 9, and that's equal to 0. It's at this point that I can realize that I have the product of two things, and that product is equal to 0. By using the zero product property, I can set each factor equal to 0. So I have, or I can make this claim, x plus 8 equal to 0, and x plus 9 equal to 0. To solve for x, I'm going to need to solve each of these equations individually. So beginning with green, I can isolate x by subtracting 8 from both sides of the equation, and I get that x is equal to negative 8. For yellow, to isolate x, I can subtract 9 from both sides of the equation, and 0 minus 9 is negative 9. So I get that x is equal to negative 9. And that, well, this would be my two solutions, negative 8 and negative 9. Let's move on to example number 3, solve the equation by factoring. Here I immediately notice that the leading coefficient is not 1, we have a 3. On top of that, my three terms, the only thing that they have in common is a factor of 1. When we are in this situation, that's when it will be a good idea to apply the box method. And to apply the box method, here's what you do. You grab your leading term, that's 3x squared. You're going to record it on the upper left. Then you will grab your C term. In this example, that's going to be the positive 4, and you're going to record it on the bottom right. To find the two missing entries, we will use a variation of the x method. This time, grabbing the value of a times c, that will be the 3 times the 4, giving us a 12. And the b term, that's going to be negative 13. We need to find two numbers that when you multiply them together, you're going to get 12. But if you decide to add them, you should be getting a negative 13. And after some trial and error, we'll come to the conclusion that the two numbers needed are negative 12 and negative 1. Negative 12 times negative 1 is positive 12. But if you add negative 12 with negative 1, you'll get the negative 13. So these are the two values that we are going to record on these missing entries. Here it doesn't matter which number you decide to put here on the bottom and on the top. So I'll put -12 on the bottom and I'll put the -1 here on the top. Keep in mind that these two values are basically the terms that make up the x term, the middle term. So I have to include the x here. Now that I've completed the box, I need to get the numbers on the outsides. And to do that, I'll begin by getting the greatest common factor of the bottom two terms. So that's the -12 and the 4. The greatest common factor here is going to be 4. Now, because the leading term here is negative, we're actually factoring out a -4. Next, I'll get the GCF of the right column. That's the -1x and the +4. So the greatest common factor here is going to be 1. But again, because the leading term is negative, this is going to be a -1. To get these two terms, I can guess strategically. So here we have -4. So -4 times what value is going to give me -12x? Well, if we think about it for a couple of seconds, we'll come to the conclusion that that should be a 3x. And now to get this value here on the left, we do a similar process. So 3x multiplied by what value will give me a 3x squared? And that is going to be x. And we can verify this quickly. X times 3x is 3x squared. X times -1 is -1x. -4 times 3 is -12x. And -4 times -1 is +4. That means that I can rewrite this trinomial on the left as x minus 4 multiplied by 3x minus 1, and that is equal to 0. And now that I've factored, I can make use of the zero product property, noticing that I have the product of two things, and that product is equal to 0. So I can make this claim: x minus 4 is equal to 0, and 3x minus 1 is equal to 0. I'll solve both equations to get the values of x. So beginning with green, here I can add 4 to both sides of the equation, and I get that x will equal 4. For yellow, I can begin by adding 1 to both sides of the equation, and I'll get that 3x is equal to 1. To isolate x, I divide by 3, and I get a value of x equal to 1/3. And those are my two solutions, +4 and 1/3. Let's continue with another similar example. Example 4, solve the equation by factoring. Just like in example number 3, we're in a similar scenario where the leading coefficient is not 1. Here we have a 6, and the only thing that we can factor out of this trinomial is a 1. Therefore, I'll use the box method to find the factors that will multiply into this trinomial. And to do that, I'll begin by recording the leading term on the left. That would be the 6x squared. And I'll record the c term on the bottom right. That would be the +12. And to find the two missing entries, I'll use a modification of the x method. I'll begin by recording the value of a multiplied by c. So here that'll be the 6 multiplied by the 12, we get a 72. And the b term is +17. I need to find the two numbers that when you multiply them together, they give you a value of 72, but if you decide to add them, they should be giving you a value of 17. And after some trial and error, you're going to come to the conclusion that the two numbers are going to be 8 and 9. 8 times 9 is 72, but 8 plus 9 is 17. So I'll fill in these missing entries with an 8x and a 9x. Next, I'll get the GCF of the bottom row. That would be the GCF of 8x and 12, which is 4. And then I'll get the GCF of the right column, the GCF between 9 and 12, and that would be 3. To find the two remaining values, we can guess strategically. So here I have a 4. So 4 times what value will give me an 8x? Well, that would be 2x. And now, 2x multiplied by what value will give me a 6x squared? That would be a 3x. And I can verify this very quickly. So 3x times 2x is 6x squared, 3x times 3 is 9x, 4 times 2x is 8x, and then 4 times 3 is 12. I did this correctly, so now I can factor this trinomial as the product of 3x plus 4 and 2x plus 3. And that's equal to 0. And now that I factored, I can make use of the zero product property, noticing that I have the product of two things, and that product is equal to 0. So I can make this claim 3x plus 4 is equal to 0, and 2x plus 3 is equal to 0. I'll begin by solving the green equation. So here I can subtract 4 from both sides. That's going to leave me with 3x equal to negative 4. And to isolate x, I can divide by 3. And I get that x is equal to negative 4 over 3. That's my first solution. Now to get my second solution, I have to solve yellow. So here I can subtract 3 from both sides, and I'll get 2x equal to negative 3. And to isolate x, now I can divide by 2, and I get that x is equal to negative 3 over 2 as my second solution. Let's continue to example number 5, solve the equation by completing the square. To complete the square, we use the x squared term and the x term, so I'll move the constant to the other side of the equation. I can do that if I add 32 to both sides of the equation, and that's going to leave me with x squared plus 4x, and I'm going to make some room since I'm going to complete the square. And then on the right hand side, I'll have 32. To complete the square, I need to add a value that will give me the perfect square trinomial. And since we have an equation, whatever I do to one side, I'll have to do to the other. To complete the square, I need to grab the b term, divide it by 2, and then square it. The b term is going to be 4 since that's the coefficient of x. So here I'll graph 4, divide it by 2, and square it. Whatever I do to the left, I'll have to do to the right. So on the right, I'm also going to add a value of 4 over 2 to the second power. On the left hand side, I now have the perfect square trinomial x squared plus 4x, and simplifying what's inside of the parentheses, 4 over 2 is going to give me a 2. And then we have quantity squared. That's going to equal 32 plus 2 quantity squared. Now I can exchange the trinomial, the perfect square trinomial, for its binomial squared by grabbing x and 2. So we have x plus 2, and then that's going to equal 32 plus 2 to the second power is 4. With a little bit more simplification, we have x plus 2 squared equal to 32 plus 4, which is 36. Because I want to isolate x, I'm going to need to get rid of the square first. And I can do this if I square root both sides of the equation. On the left, the square and the square root are going to cancel out, leaving me with x plus 2. And on the right hand side, the square root of 36 is 6. But since we have, or since we're taking the square root, we have to take into consideration the negative solution as well. And now I'm pretty much done. I just subtract 2 from both sides, and I have that x is equal to negative 2 plus or minus 6. And simplifying, I have x equal to negative 2 plus 6. That's the first solution. The second solution is going to be negative 2 minus 6. So beginning with the top, negative 2 plus 6 will give me a positive 4. And then on the bottom, negative 2 minus 6 is going to give me negative 8. So 4 and negative 8 are my two solutions.